In this video, we're going to talk about normal distribution. It's basically kind of data will sit sometimes normally distributed, which there's a whole stats definition to it. So we're going to kind of just give a brief idea of it. So here's what it looks like. Well, it looks like this, that you have this set of data and the majority of the data sits kind of around the mean. All right. And there's a certain percentage of it that sits around here. So if this is the mean, then from here to here, whatever that value is, 68-ish% of the data is going to usually lie within that. So if you're talking shoes, whatever an average shoe size is, then a certain population of the shoes are going to kind of fit within that range, right? So once you start to get to some bigger sizes, not as many people are going to fit into that category, or smaller sizes, not as many people are going to fit into that category. And then you start to talk about really small feet versus really large feet, basketball player, kind of like huge kind of ski-ish feet. So each category, so these are called standard deviations. Okay, so let me kind of try to build this a little bit. Okay, so what does it look like? It looks like this. Okay, and so we're going to generalize this and try to make sense out of that chart. So here is the average, a little X with the line on it. Okay, so that is typically right in the middle. That average also has a tendency to be your mean. It is the mean, but it's also the median. They end up being the same thing, and then it also ends up being the mode. So most of your data will fit between here and here. Okay, so in this category, this is one standard deviation. So you're one standard deviation higher or you're one standard deviation lower. And so we talked about standard deviation on the last one. And so that, remember, standard deviation represents the spread of your data. So this one standard deviation left should represent about 34.1% of the population. And then on the other side, 34.1% of the population. So 68% of the population kind of fits plus or minus a standard deviation, right? So if the average shoe size is a 9 and standard deviation is 1, then we're talking between 68% of the people are going to fit between size 8s and size 10s. So then if I'm purchasing shoes for a company, I'm going to make sure that that's the majority of the shoe sizes that I have. And then of course, I'm going to buy some more shoes, but I don't need to buy as many because you're talking about a smaller chunk of the population that are going to be looking at those shoes. So when you're 2 standard deviations out, that is broken off into 13.6%. It's kind of fitting in that category on both sides. So 13.6%. So then what this piece of paper is that now 2 standard deviations fits 95% of the population. So again, if you're buying shoes for a big company and you want to make sure that you're covering enough shoes and you're not losing sales, but you're also not buying too many, right? You don't want them to just sit on the shelves. Then if you covered sizes, again, if that was a 9 and this is 10, 11, this is a 9, 8, 7. So between 7 and 11 shoe size, that's going to cover 98% of the population. That's the majority of the shoes you're going to cover. Right? And the most of them you're going to buy are somewhere in between that 8 and size 10. You'll buy a little less of those sizes and then a little less of those sizes. And then maybe those are special cases. All right. Or maybe you hold very, very minimal of those. Okay. So that's kind of the idea behind it. So let me go off into one more, that if you are 3 standard deviations above, then you are going to be in this 2.3% chunk on both sides. So 2.3%. And then if you are anything further than that, you're looking at this category and this category are 0.1%. 0.1% are more than 3 standard deviations above. Okay, so if you go out to 3 standard deviations above, you're talking about covering this chunk of the population. You've covered 99.7% of the population. Okay, so anything outside of that are exceptions, pretty much. Okay, and I could talk about a lot of things: salary, values of homes. It could be talking about heights, could be talking about shoe size. It could be talking about a lot of different things. SAT scores, all sorts of things. So we're going to take that and kind of build our own version of this, and then we're going to ask some questions on it. All right. So I'm going to use a little bit of space. So I'm going to build my normal distribution. I want to put our numbers kind of related to this problem. And I don't think this is enough space. So I'm going to put it kind of here and then see if I have enough space to do the math over here. All right. So it says an AutoZone Duralast Gold automobile battery has a population mean of 48 months. That just means that their sample that they took, well, all the batteries in general seem to have an average life of 46 months with a population standard deviation of every 4 months. Okay. So what does that mean? So let's build what that means. So our graph looks like this. We have an average value right here, and that is our 46 months. So the average lifespan of that battery is 46 months. Okay, it has a standard deviation of 4 months. So this is going to be 50 months. This is going to be 42 months. So that means that, again, if you break this up, and you are selling these batteries and you have a warranty and stuff like that associated with it, that from 42 to 50 months is going to cover 68% of those batteries on average. Okay, so whatever your warranty is, are you paying out on that warranty? Or just in general, it's good to know how long the batteries last. So 68% of those batteries are going to last somewhere within that window. Okay, and then if we go on another, we're looking at 38 months or up to 54 months. That's going to cover 95% of the batteries. So 95% of the batteries are going to last between 38 and 54 months. All right, so that's pretty good. So you're really covering the lifetime of that battery right there. Okay, but then are there exceptions? Sure. Does stuff break earlier than that? Sure. So that is 34 months and 58 months. So maybe you have a 36 month warranty would be down here. So that's really going to be the rare exception for those batteries. So if it's a 36 month, it's going to really cover, 36 months would be here. And if my battery lasted that long, I'm outside of the window. So I'd really would be, you're covering the majority of the batteries, and you wouldn't have to pay for that warranty. Like if you're the company that is paying out on the warranty. Okay. So let's see what kind of questions I got. So if in order of 100 batteries, what percent do you expect to last less than 54 months? Okay. So that's our percentages. We need to figure out where we're at. So 54 months is here. So I can add 1, 2, 3, 4, 5, 6 of these things together. Or I can do 1 minus these two, right? Because if they want it less than, then I can also figure out what's greater than and then just subtract it from 1, okay? Or from 100%. So it's totally up to you. Depends on how you want to look at it. But 54 is the 2 standard deviations. So we would be adding 0.1 plus 2.3 plus 13.6 plus 34.1 plus 34.1 plus 13.6. And I think that's it because we were going out to 54 months. Okay, so that would be what adds up to less than. So let me add all that up. We have 0.1 plus 2.3 plus 13.6 plus 34.1 plus 34.1 plus 13.6. So 97.8% of your battery should last less than 54 months. Okay, so that's one question. And then it says, how many batteries do you expect to last at least 54 months? So again, this is kind of the other side of that. So at least 54 months is going to be these two categories. So either I'm adding these two categories together. So, and I'll show you the other way on it. So it's 20, or it's 2.3 plus 0.1. So that adds up to 2.4. Right, and then we went around to the nearest battery. Sorry, how many batteries do you expect? Hold on, there's an extra part of this. So we got to get our percent. So we're going at least 54 months, which is 2.4%. Right. So that's how many are going to last. So all I did was I added that and that together. But that's great. We have 2.4%. However, we want to figure out how many batteries, and we bought, and we ordered 100 of them. So 100 of them, 2.4% of them, of that would be 100 times 2.4%, which is 0.024. So if we multiply that out, we are looking at 100 times 0.024. And we're going to get 2.4 batteries. But they want, that doesn't make any sense. So we want the nearest battery. We're saying about 2 batteries. All right, so out of those 100 batteries, only 2 are really going to last 54 because the average is 46. So you're looking at 8 months further than that, almost a whole year-ish that battery lasts. So that's pretty good. So that's why there's only about 2 batteries that's going to happen. Okay. So that is normal distribution, and it's kind of how data fits, and you'd be surprised as to kind of how applicable that is in the real world. Thanks.